Okay, today we will be talking about the finite difference as a topic. The finite difference. And so, mass 209 is the course code. Mass 209 is the course code, and we'll be talking about finite difference. And we said that if y is equals f of x be any function given by the values y0, y1, y2 as we approach yn, which corresponds to an equidistance x0, x1 as we approach xn of any independent variable system, then y1 minus y0 is a first difference. y2 minus y1 is also a first difference. Now let me explain that. Now we have two operators, this and this, right? Now what this operator does is that it is called a forward difference operator. A forward difference operator. And this operator is called a backward difference operator. That is why you can see that it is an opposite. Words and opposite. It's an opposite of this particular person, right? It's an opposite. They are opposites of each other. Now this operator y, if I say what is the forward difference of y0, what I'm simply saying is that where we are going to y1 minus where we are coming from. So assume that we are on the number line and you call this place y0, this place y1, this place y2. y0 is the forward difference of y0 will be where are you going to y1 minus where are you coming from y0. Is that clear? And so we now said that the forward difference of y1 is y2 minus y1, where we are going to, like I said, minus where we are coming from. The same thing happens when I say what's the forward difference of y2. What you'll be telling me is y3 minus y1. Those are what we call forward difference. So the difference between the change in y0 is y1 minus y0. The change in y1 is y2 minus y1. Now this particular symbol, as you can see it here, is called the forward difference operator. The forward difference operator. What does it do? It helps you checkmate the differences between where you are going to minus where you are coming from. And so we said, so let me clean this part quickly. And so we said change squared of y0 is the forward difference squared of y0 is the forward difference of y1 minus y0. Now this particular symbol, which is called the forward difference operator, has characteristics. What are the characteristics? What are the characteristics of the forward difference operator, this particular symbol? Number one characteristic is that it can obey the law of indices. It means that the forward difference of m, when multiplied by the forward difference of n, is the forward difference of m plus n. Number two is that the forward difference of a constant, is equal to 0. Why did I say so? Let's assume that here is 2, the next person we are going to is 2, the next person we are going to, so constant means something that is appearing every time. Is constant, appearing every time. So if I say, what's the forward difference of 2? You just tell me 2 minus 2, which is 0. So the forward difference of a constant is 0. The third is that it has the ability to open brackets. So if I say the forward difference of, let's assume f plus or minus g. Did you see that? So you can simply say forward difference of f plus forward difference of g, or forward difference of f minus forward difference of g. So it can open brackets. That's the ability to do what? To open bracket. Let's not forget. Now we want to observe some very notable questions about the forward difference. We want to observe some very notable questions about the forward difference. We were asked to expand. Let me start all over from here. We were asked to expand the forward difference squared of y naught, like I said. So we can say that the forward difference of y naught is the forward difference multiplied by forward difference multiplied by y naught, right? Because I said it has the ability to expand. Then I said that the forward difference is into the bracket of the forward difference of y naught, right? And I said, let us appreciate the fact that this person is inside bracket. So this guy, by definition, is that we say the forward difference is into the bracket of, if I change this or if I express this, what I'm saying is, what is the change in y naught? What is the change in y naught? And so you find out that the change in y naught is y1 minus y naught. Like I always say, I said where you are going to minus where you are coming from. Now, if we have it like this, and you can remember that in one of the characteristics I said it can open brackets up, it means that this can be likened to forward difference of y1 minus forward difference of y naught. Is that not? And so if we express this again by definition, this guy means y2 minus y1, right? And this guy means, if I express this person, the forward difference of y naught, what you'll be having there is y1 minus y naught. Is that correct? And so by definition, this is y2 minus y1 minus y1 plus. Why is it a plus? It is a plus because when you multiply minus times minus, you're going to have a plus. So we say plus y naught. And so in essence, what we are trying to say is that the forward difference squared of y naught is y2 minus 2y1 plus y naught. Did you see that? So it was very important for us to learn the characteristics of a forward difference operator. Without learning the characteristic, we would not be able to find out, or we would not be able to know that this can open brackets. Is that correct? Good. Now let's look at some other brief examples. If we were asked to give an account of the forward difference cubed of y naught, what would we have said? We would have been able to say that the forward difference multiplied by the forward difference multiplied by the forward difference of y naught. And so we have the forward difference multiplied by the forward difference multiplied by. Ask yourself, what is the definition of this? By now, we now understand that the definition of forward difference of y naught is y1 minus y naught. Is that not? And so from here, we can be able to say that the forward difference, did you see that? All squared should be y1 minus y naught. Did you see that? And so, because we have been able to know that forward difference has the ability to open brackets, we can now say that the forward difference all squared of y1 should minus the forward difference all squared of y naught. Did you see that? So, having said all of these things, what can we derive from this junction? This is simply saying that the forward difference multiplied by the forward difference of y1 minus the forward difference multiplied by the forward difference of y naught. Did you see that? So we are just simply doing what? We are just simply breaking them down. And so you find out that from here, the forward difference, when multiplied by this is y2 minus y1 minusing the forward difference of, what is the forward difference of y naught? The forward difference of y naught is y1 minus y naught itself. Did you see that? And so from here, we can be able to say that the same 4 difference can also multiply, right? And so if those 4 difference multiply this, you have the 4 difference of y2 minus the 4 difference of y1, right? Minus, so what is the 4 difference? This is the 4 difference of y1 minus the 4 difference of y0. Did you see that? So as we have had it like this, once we'll be able to get here, we've been able to solve our problems. We've been able to solve our problems. And so from here, by definition, by definition, we can now say that the 4 difference of y2, haven't seen it here, the 4 difference of y2 is y3 minus y2. Did you see that? And then minus the 4 difference of y1 is y2 minus y1. And then minus again, did you see that? Minus again, we have, what is the 4 difference of y1? We say y2 minus y1. Okay, then minus, what is the 4 difference of y0? The 4 difference of y0 is y1 minus y0. Remember, we said where you are going to minus where you are coming from. Where we are going to minus where we are coming from. And so, from there, we can then express and say y3 minus y2 minus y2 minus times minus plus y1 minus y2 plus y1 minus y1, right? Minus y1. Let's see that together. This is minus y2 plus y1. Okay, this is minus y1, but minus times minus is plus y1. Then minus times minus is also plus, so plus times minus is y minus y0. So all we are having is y2, so this is minus 1 minus, this is minus 2 y2 plus, so okay, minus 2y2, collecting like terms here, and minus y2 here, y1 plus 3y1 minus y0. And so what we have is y2 minus 3y2 plus 3y1 minus y0. Did you see that? So this translates, did you see that? This translates by definition the forward difference cubed. This is the expression for the forward difference cubed of y0. Did you see that? Finite difference. And so over the years, we've been able to solve problems like this using another approach. We call that approach the Pascal triangle approach. So let's take note of that, the Pascal triangle approach. So let's observe this particular function. We said y2 minus 3y2 plus 3y1 minus y0 is called the forward difference cubed of y0. The forward difference cubed of y0. So we want to use an approach called the Pascal triangle approach. The Pascal triangle approach. So if you follow through the class, you'll be able to understand basic concepts of Maths 209. So we said the Pascal triangle approach. The Pascal triangle approach. Now what is the Pascal triangle? Remember, when you have 1, you have 1, 1. 1 plus 1, 2, you have 1, 1. 1 plus 2, 3. 2 plus 1, 3, you have 1, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4, you have 1, 1. So we say this is a degree of 0, this is the degree of 1, this is the degree of 2, degree of 3, degree of 4, right? But because we are dealing with degree of 3. The question says forward difference cubed. Did you see that? The question is saying forward difference cubed of y naught. So we are dealing with the degree of 3. And so we pick this out. We pick this particular person out. That's the person we are going to be using. Alright? That's what we're going to be using. And so because of that, we then said that this is 1, 3, 3, 1. So when you are using a Pascal triangle approach, your labeling starts from the back. Your labeling starts from the back. So we are having a positive. Let's not forget, this is plus, minus, plus, minus, plus, minus, plus, minus, plus, plus, minus, plus, plus, minus. So because we are at degree 3, we are saying plus, minus, plus, minus. And so we are saying plus 1, minus 3, plus 3, minus 1. And so because of that, we are labeling from the back. So here will be our y naught, here will be our y1 in ascending order. So we are going like this, from smallest to greatest. You see that? From smallest to greatest. From smallest to greatest. So we have y0, y1, y2, and y3. So in essence, what we are simply saying is y3 minus 3y2 plus 3y1 minus y0. This is the forward difference cubed of y0. Did you see that? Again, this is the Pascal triangle approach. This is the Pascal triangle approach. I'd like for you in your meantime to try this. Using the Pascal triangle approach, solve for the forward difference to the power of 4 of y0. You can try that out at your leisure time. The forward difference to the power of 4 of y0. Very, very simple. Again, we move further, right? We move further to something called the difference table. Moves further to something called the difference table. Difference table. Let's look at that quickly. Let's look at that concept quickly. So we are asked to construct a difference table. So a difference table, let me bring that to your hearing. A difference table is a convenient method. A convenient method. A difference table is a convenient method for displaying successive differences of a function. It's used for displaying successive differences of a function. And so because of that, let us look at some basic examples. It said construct a forward difference table. For the sake of time, I'm shortening this to difference table. D.T means difference table. All right. So construct a forward difference table for the following data. For the following data, we have x and we have y. We have 0, we have 0. We have 10, we have 0.174. We have 20, we have 0.347. We have 30, we have 0.518. We want to construct a forward difference table for this value. Remember, do not forget that I said whenever you are doing a forward difference table, you are saying where you are going minus where you are coming from. Is that not what I said? Where you are going minus where you are coming from. And so because of that, let us construct the difference table. We have x here, we have y here. What are the values in x? The values in x are 0, 10, 20, and 30. Did you see that? The values in x are called 0, 10, 20, and 30. And for y, we have 0, 0 0.174, 0 0.347, 0 0.518. Is that not? Now, what do we do here? We say, what is the forward difference of y? So the forward difference of y is where we are going to minus where we are coming from. So this should minus this. So we are saying 0 0.174 minus 0. We're going to be having 0 0.174. Here we are saying this should minus this. So where we are going minus where we are coming from. And so we have 0 0.173. And then here we have 0 0.518 should minus 0 0.347. We have 0 0.171. Is that clear? And so from there, you'll be able to progress to what we call the forward difference squared of y. Did you see that? And what do we mean by the forward difference squared of y? It means this should minus this. From there we have minus 0.001. This minus this, you have minus 0.002, right? And then we have the forward difference cubed of y. The forward difference cubed of y means this where we are going to minus where we are coming from. We have minus 0.001. Did you see that? All these are put together to know or to make us understand how a difference table works. So this is how a difference table should be plotted in case you are asked in your test or your exam. Construct a forward difference table. This is how it's going to look like. Let's look at another example. Let's look at another example. We have said construct a difference table. Construct a difference table for y equals f of x equals x to the power of 3 plus 2x plus 1 for x equals 1, 2, 3, 4, and 5. Construct a difference table for this value. And so when you want to construct a difference table, let's look at that together. Let's look at that together quickly. We said, what will be f of 1? F of 1, that means slotting 1 into this function. F of 1 will be 4. F of 2 will be 13. F of 3 will be 34. F of 4 will be 73. F of 5 will be 136. Did you see that? And so it is easy for us to construct a forward difference table when we have this data. And so what is f of x? F of x is the same thing as y, right? Y is a function of x. So f of x is the same thing as y. So let's do that together. We have x here written here. We have y here. So we have 1, 2, 3, 4, 5. And for y we have 4, 13. Why am I writing 13? Whatever, because this is f of x. So whatever value I'm having here, I'm slotting it into this function and I'm producing y's. So 4, 13, 34, 73, and 136. So I said the change in y, the forward difference of y, is where we are going to 13 minus where we are coming from 4. So we have 9. The next is where we are going to 34 minus 13. We have 21. We have 39. We have 63. Did you see that? And so here we have the 4 difference squared of y. So this minus this, we have 12. This minus this, we have 18. This minus this, we have 24. Again, we move again. We have 4 difference cubed of y. Did you see that? So this minus this is 6. This minus this is 6. And then at the end, we have the 4 difference to the power of 4 of y. This minus this is 0. This is the forward. This is the forward difference table. This is the forward difference table of that function or of that question. Is that clear? All right. So as we have seen these samples, we've had a rigid knowledge of the forward difference table. See you in my next class. All right.